This video should answer the question, what is a limit? And also, how do I find limits numerically and graphically? First off, let's answer the question, what is a limit? My definition of a limit is basically that a limit is a trend or an end behavior. Now I want to make a distinction that doing a limit is not simply evaluating a function. So for example, let's say we have the function x squared and we have x equals 2. Okay, obviously 2 squared is 4. Great. Now a limit is a little bit different. The way a limit would work is we say the limit as x approaches 2 of x squared equals 4. The reason that this isn't a limit is because there's no what's called a limiting process going on. Whereas with the other side here, there is a limiting process, and I'm going to show you that right now. Here's our limit. Limit as x approaches 2 of x squared equals 4. Notice how I said that. Limit as x approaches 2 of x squared is 4. The way that sentence is parsed out, you basically end up with the limit is 4. And you have the extra information that x is approaching 2. The function that we're talking about is x squared, and the value of the limit is 4. Some quick things to note. First off, x is approaching 2. That means that x is not equal to 2. Okay, x is getting really close to 2, but isn't actually equaling 2. Notice that 2 is an x value here, and 4, this is a y value. Alright, so the way that I'm going to explain this limit is with a handy-dandy xy chart. So I'm going to say here are the x values and here are the y values. Remember that y is simply just x squared in this example. So we're going to start off with some numbers that are close to 2 for the x values. So remember x is approaching 2, so let's start with 1.9. And then we're going to get closer, 1.99, 1.999. Alright, so I'm approaching 2. Notice that these numbers here are getting close to 2. And I'm going to approach 2 from the other side also. So I'm going to do 2.1, 2.01, and 2.001. And now what I'm going to do is I'm going to evaluate what x squared is at each of these x values. So I simply plug in 1.9 squared, and I'm going to get 3.61. Then I'm going to continue this process. So 3.9601. Haha, I can write fast. This is nice. So notice that these y values, notice x values are trending towards what? They're trending towards 2. Look at that, 2. And the y values are also trending towards a number, okay? 3.6, 3.96, 3.996. And on the other side, 4.1, 4.04, 4.004. Okay? The y values are trending towards 4. This relationship, okay, as x approaches 2, as the x values approaches 2, the y values are approaching 4. Okay? In this example, we've never plugged in x equals 2. Okay? We're always just picking values of x that are close to 2 and seeing what the y values trend towards. Here's why it's important to not just plug in the number. Okay, we could have just plugged in the number and got 4, but here's an example of a problem where you can't just do that. Here's a problem. So here's our function in blue. Okay, notice that going along, and then here it jumps up to that point up there. Uh-oh. And then it keeps going along down here. So basically a straight line with a hole and a point up there. And I want to know two things. I want to know what f of 2 is, and I want to know if the limit as x approaches 2 of f of x is. So let's do f of 2. For f of 2, we find the x value 2, and we go to where the y value is. It's not down here because there's a hole, so we go up here. So it's 1, 2, 3. Alright, versus the limit of, as x approaches 2, of f of x equals. Now for this, I'm going to use our little chart. So x is approaching 2, so I'm going to pick x values that are close to 2. 1.9, 1.99, 1.999, etc. 2.1. And then I'm going to find the f of x values. Well, it's a straight line at -1, so the f of x value for x equals 1.9 is just -1. Same thing with 1.9, -1, -1. They're all -1. Ooh, interesting. So to evaluate the limit part of this, we have to look at the trends. Here, x is trending towards 2, which is good because that's what we wanted, and f of x is trending towards -1 because that's the pattern, that's the trend. So here, the limit as x approaches 2 of f of x for this graph is -1, because as x gets close, as we creep up on the x value for 2, the y values stay at -1. None of these y values are jumping up to 3, so the limit here is just -1. And that's really it for a graphical interpretation of the limit. So what you will need to know for a test or a quiz or the AP exam, or just for life in general, is how to say this idea here in words. And the way to do that is the limit as x approaches a of f of x equals or is c. There's our sentence all nice and pretty. And here is a graph to go along with it. So we have some nice axes like that. We have our graph f of x. I'm going to draw it in blue, just like in the limit definition there. So there it is. Okay, and let's say, so here's the x value. Our x value is a. X is approaching a. And then that y value here is going to be c. Now notice that f of a could be anything else. It doesn't have to be c. So f of a could be something else like b, and be somewhere like up here, and that's okay. All we care about for the limit is that the trend as x approaches a from both sides, what are those y values going towards? And we can see that here they're going towards c and not towards b. There are no other y values up in that region. So that's one thing you need to know. The other things you need to know how to do are how to find limits on a graph. We'll do some practice of that in class. And then the last thing that we did was that limiting process with the number charts. This is more conceptual, so if you can picture doing a chart and then finding the end behavior of those y values as you're doing the limit, great. But this is not a skill that you need to know how to do for the test or the AP exam or anything like that. So enjoy.